Alright, now we'll look at a couple examples for this section. And algebraically determine characteristics of a quadratic function expressed in factored form. And here's a factored form. So, first example, given the following function, determine the x-intercepts. First, what we're going to look at is that there's a negative, so that should tell us that the graph has a maximum point that's going to be pointing down when we go to sketch it. So that's going to be important in this step down here. So first, now determine the x-intercepts. So we look at our factored form, and either x plus 2 equals 0 or x subtract 4 equals 0. And solving the equation, so our x-intercepts are negative 2 and 0, and 4 and 0. So since we have to graph, we can look down here. So negative 2 and 0, and 4 and 0. We know that the graph is going to have to point down because of the negative. Come back up, axis symmetry. Well, for the axis symmetry, we're going to need to find our vertex. Remember, the axis symmetry is the average between 2 points that are at the same height. Now we know both these points are going to be at the same height. So you think about your sketch here, both are going to be at the same height. The axis symmetry should work out to be running straight down here. Now to prove that, without having to do a graph, we take both the values. Again, use two values that are going to be at the same height. Use two x values that are going to be at the same height, we should say. You take the average of them. 1. So x equals 1. Coordinates of the vertex. Well, we know that our x value of the vertex is going to be 1 because it has to be the same as the axis symmetry. We can take this value, put it back into our graph up here. So where we see x, we'll put 1 back in. Negative 3 times negative 3 negative times the negative is going to give us a positive. 3 times 3 is 9. So coordinates of the vertex are 1 and 9. Let's go over 1. Up 9. And now determine the y-intercept. Where does the graph come through here? We get the y-intercept. Remember that your x, that on the y-intercept, the x values are equal to 0. On the x-intercept, remember that y is equal to 0. So here, for the y-intercept, we know our x value should be 0. Second. Okay, so we put 0 in for x. So if you put 0 in for x, you'd have 0 plus 2, or just 2. If you put 0 in here, 0 subtract negative 4, negative 4. Negative times 2 is negative 2. Negative 2 times negative 4 is 8. Now we connect our graph, or connect our points, sketch our graph, up, over, down through here. Now the range of the graph. Now the graph has a maximum. We said whenever the graph has a maximum, it's always going to be y less than. In this case, y less than the y value of the vertex, y less than 9. Now example 2. Again, this is in factored form. Determine the x-intercepts. So when you determine the x-intercepts, the y value is 0. and down. Either this works out to be 0, so 2 times some number is 0, so x has to be 0, or x plus 4 is equal to 0. Bring the number over. X is negative 4. So the x-intercepts are 0, 0, and negative 4 and 0. Go further down. So my x-intercepts are 0, 0, negative 4 and 0. Now looking here, we should also know that our axis symmetry should be running down here in the middle. And to find that without the graph though, you would take your two values here, add them together, and divide by 2. Negative 4 divided by 2, negative 2. So you're getting the spacing between 2 points that are at the same height. Now the a value of this equation will be positive, so the graph must point up. This graph goes up, and that means it has a minimum value. Coordinates of the vertex. We know what the x value of the vertex is. Negative 2. We don't know the y value. So we take x equals negative 2, and we're going to substitute into our equation. Y equals 2x, x plus 4. So everywhere we see x, we put in negative 2. So negative 4 times 2, negative 8. So 2, negative 8. And now the y-intercept, last point for us to complete the sketch. So for the y-intercept, remember that the x value is 0 on the y-intercept, anywhere along this line up and down. So anywhere along here, along your y-axis, the x value is 0. So we're going to take our equation, and where we see x, everywhere we see an x, we are going to put in a 0. Alright, 2 times 0 is 0, and 0 times, well, 0 times anything is going to be 0, but just to finish it out, 0 times 4, 0. And we know that because we told we had an intersection point here. That's on both the x and y axis. So I'm going to graph this here, and then back down to there. And the range, and whenever we have a minimum value, we say that y is greater than or equal to, well, what is that value? Negative 8. Okay, last example. So here's our factor form of the equation. The a value is negative, so we know that the graph has a maximum value that should look like that. The x-intercepts, we say the y value is 0. So when you're looking for x-intercepts, you know that anywhere on this axis here, the y value is going to be a 0. So again, anywhere across here, y value is 0. So negative 3, x minus 1, x minus 1. So this has no value with it, or no, it doesn't have a value, it has no variable with it. So we're just going to leave that out. We'll concentrate here. X minus 1 equals 0. And now you have the same thing again. X minus 1 equals 0. So x equals 1, x equals 1. So the x-intercept is 1, 0. So it's down here. This is going to be our x-intercept right there. There's only going to be one x-intercept. You might think up here there's two, but really it's the same number. Term the axis of symmetry. Well, there's only one point there. So the axis of symmetry is going to be at that point. Coordinates of the vertex. If you took this x value and put it back in to the equation, so you have negative 3 x minus 1 times x minus 1. And perhaps you figured out now that you don't need to put it back in to know what the vertex is going to be. 1 minus 1 is 0. This is all being multiplied, so you'd have the answer is going to work out to be 0. Negative 3 times 0 is 0. So what's happening here? So your axis symmetry is running up and down here. The y-intercept, where would a graph cut through the y-axis? Remember, for the y-intercept, anywhere along here. Your x value is 0. 0 minus 1 times 0 minus 1. 0 minus 1, negative 1. And then negative 1 again. Negative times a negative times a negative is a negative. And 3 times 1 times 1 is 3. So right there. Now the graph, this is the axis symmetry. So your one space over there. So for the graph to be symmetric, you should also have this point should be on the graph. The graph is going up. And I put this point in just to help me make the graph a little easier. Okay, whatever is at this height, if I fold the graph over, I should be at the same height there. And the range, you have a maximum, so y is always less than or equal to that maximum point, which is 0. And here are some questions that we can look at in class.